Okay, dear learners, we are with the last and the final experiment, which is the 10th experiment of linear algebra laboratory, where you're going to do multivariate linear regression. You can see this program here, that is multivariate linear regression. As mentioned, this program also doesn't have any code runner environment to run the program. We'll be doing this in Jupyter Lab only. Okay, so here is the experiment for you. So the experiment deals with a file system. All right, that means you are going to read a file, a CSV file like this. So the libraries that we are going to import here is pandas. Okay, that is dealing with a database system. So hence we are going to import the library pandas, and you are giving it an alias name PD. Then you're going to import yet another library, linear model, which is available from sklearn, which is being used to train your data to create a model. All these things you're going to do with this sklearn linear underscore model. Then you're going to declare a data frame which is equal to, using the pandas command, which is read underscore CSV, you're going to open a file cars.csv. So this file should definitely exist in your directory like this. So this is your cars directory. Actually, this program is dealing with uh, the weight, the volume, and the carbon dioxide emission of a car. So here there are set of data, like there are around 36 vehicles and their model, their cubic capacity, that is a cc or the volume of the piston, then the weight of the car, and finally the carbon dioxide emission. So what you do here is you will be giving the weight and the volume here, and a corresponding carbon dioxide emission will be given in the next column. Okay, so you're going to train the whole system with this data. So whatever car that you have, the car's brand as well as the model, the volume, the weight, everything is being given, and the corresponding carbon dioxide emission is also given to you. So your aim is to actually identify the carbon dioxide emission of an unknown car. All right, an unknown car, which for which you will be given the volume as well as the weight. So you have to predict its carbon dioxide emission. So for that, we are making use of these libraries. We'll just see. So here you are having the library sklearn linear underscore model to do that. So the next thing that you're going to do is you are going to create a model which is being done using the regression is equal to linear underscore model dot linear regression. So this model is being created now. Now what you do is you will be fitting that model with data, which all data, this x data and the y data will be fitted onto it. See this, the x and y are being actually created as data frames, where you're going to get, I mean, the data frame is already created, you're going to get these values onto it, the weight, the volume, as well as the carbon dioxide. Now you're going to fit this regression variable using these elements, and thereafter you're going to print the regression coefficients. Once you have done this fit for the first time, if the system is going to run, means it will take a little bit of time in order to train the model. Okay, so here is where the model is being trained, and afterwards you will be getting the regression coefficients if you get this function, and in order to get the intercepts you have to do this along with an underscore. And after that you're going to test your system by the newly introduced data, which is you're going to introduce a new weight 3300 and a volume of 1300. So your aim is to get the carbon dioxide emission. So for that you're going to load this data frame as the weight and the volume, and thereafter you're going to get the predicted CO2 like this. So it is simply regression dot predict with this input data. So you'll be getting the predicted carbon dioxide emission. So you can, I'll just run this program so you can see that it will take a little bit of like a 1 second time to train this model over here, and then it will display the answer. See this? Okay, actually it didn't take much of time. It straight away displayed the coefficients, the intercepts, and finally the carbon dioxide emission. This is the predicted carbon dioxide emission. Okay, so that was the program that marks all the 10 experiments. Thank you.